video we've been talking a lot about valence electrons and electron configuration, and kind of the next step in this process is to talk about some Lewis dot structures, which can maybe be recognizable as something like this. X is just a variable for any element that we can stick in there, and all these dots around it represent electrons. But what we're concerned with in this is valence electrons, because if we're going to do every single electron in an element, there'd be a lot of dots. So to do a couple, let's pick a random element. Let's do calcium. So for calcium, we're going to write the symbol of the element, which is Ca. And then we're going to count the number of valence electrons, which in this case is really easy. It's just 2. And we're going to put them on opposite sides of each other. And that's for calcium. So we just did the dot structure for calcium. Now, if we want to do, this one's kind of easy because we just have these two. But if you want to go, stay in the same period, go all the way across to arsenic, we just put the arsenic symbol, which is a capital A and a lowercase s. And we're going to count electrons again. We have our 1 and our 2. We're going to skip over the D part because we're concerned with the valence electrons. 3, 4, 5. We know that there has to be 5 little dots around here. So we're going to go 1, 2, 3, 4, and 5. And that would be the dot structure for arsenic.
Hey everyone, it's Jason. Today we're doing some Lewis dot structures, and this is in packet, I believe, 2? Packet 3. Alright, so H2O, water. Got some hydrogen, got 2 of them, got some oxygen. So hydrogen has 1 valence electron, but since there's 2, we're going to times 2. Oxygen has 6 valence electrons in group 6. Alright, so 2 times 1 is 2, plus 6 equals 8 valence electrons. Alright, so oxygen always goes in the middle. Hydrogen goes on the sides. And we're going to put 2 electrons right here to connect, make a connection between hydrogen and oxygen. And 2 electrons that will complete the outer shell for hydrogen. So they're complete, but we still have 4 left. So we put the 2 electrons on top, 2 in the bottom. Oxygen has its octal rule complete. That's 8 valence electrons, and the oxygens have their 2. And there it is.
Okay, I'm going to be doing the Lewis structure for CH4, also known as methane. So in this you have your carbon and your hydrogen. Carbon is going to have 4 valence electrons, and each hydrogen has 1, but you have a total of 4. So how you're going to connect them is you're going to have a C, and then you're going to have an H on all sides. And these are connected because carbon is sharing this electron with hydrogen, and hydrogen is sharing its single electron with carbon. But the more appropriate way to write it will be like this, and then instead of drawing these 2 electrons, just draw 1 line, which represents your single bond of 2 electrons, and then the octet rule is complete. Carbon has its 8 electrons, and hydrogen has the 2 that it needs.
So another thing that can come across in Lewis dot structures is more than 1 bond. We've seen the single bonds, and an example of this would be CO2. After counting the amount of valence electrons, you'll see that CO2 has a total of 16 electrons. So let's start with just putting our central atom, which we know is going to be C, because there's 2 oxygens bonded to C. So we have our carbon, our oxygen on both sides. Now we're going to put a bond, just 1 bond initially, which would bring us down to 12 electrons. Then we're going to start with just putting our electrons around the outer atoms. So we've used up all of our electrons, that's 12. But as you can see, carbon only has 4 electrons, but it needs to have 8 to complete the octet rule. And a simple way of doing this is to take 2 electrons away from oxygen, making another bond between them. Because remember, each one of these lines represents 2 electrons. So now carbon has 2, 4, 6 electrons. Still wants 2 more electrons, so you take 2 from the other oxygen and put another one right there. So everyone has their 8 electrons, because there's 2, 4, 6, 8 for this oxygen, 2, 4, 6, 8 for this oxygen, and with all the bonds, there's 8 electrons for carbon, completing the octet rule. So the next Lewis dot structure problem we're going to do is I'm going to show you how to do the dot structure for polyatomic ions. And if you don't know what that is, you can look it up in the book. They're ions that have kind of a special charge. They don't have a neutral charge. This one, NH4, is known as ammonium, and it has a +1 charge. So to do this, we kind of start out just like we would anything else. We're going to get our central atom. We're going to put 4 H's around it. First thing you should do before you rush in like I did is check the number of valence electrons. Nitrogen has 5, and then there's 4 hydrogens which have 1, so there's going to be a total of 9. Well, we have even though there's 9 valence electrons for this whole compound, everything's satisfied. N has its 8 like it wants to complete its octet rule, and hydrogen really only wants a maximum of 2 because it can't hold more than that. So everything's settled, and we actually have 1 less electron than we normally should, which is why ammonium has a positive charge. So to denote that, we're going to put big brackets around the compound, and you just put the charge up in the corner.